Today we'll be talking about the exterior angles of a triangle. So I've associated this with Unit 1 and Unit 2. Unit 1 is titled Similarity, Congruence, and Proofs. We will be talking about proofs today. And Unit 2, which is right triangle trigonometry, we'll be talking about triangles, which will lead us into some prerequisites for what we need to learn about trigonometry here in the next couple lessons. So our goal today will be to find the measure of angles associated with triangles, very similar to yesterday's goal. You looked at questions like this yesterday. Let's look at this again for the sake of discovery, and let's see a relationship between some of these angles on the inside versus some of these angles on the outside. So yesterday we looked at this angle first. We noticed that this is a straight angle. Notice it's a line, so of course it's straight. Means it has a measure of 180 degrees. So if I start associating this angle with y, and let's give this one z just for the sake of giving them names. I guess I should have used numbers, but that's okay. We'll use variables for the sake of the measure of the angles. But 140 plus y should equal 180, which means that y is 40 if we subtract 140 from both sides. Then we can put together these two. So 100 plus 40 plus z should equal 180 because 100 plus 40, or y, plus z is 180 because that's the sum of the interior angles of a triangle. 140 makes 140, z is 180, subtract your 140, and z equals 40. Now from here, we can find x, because x plus z, and z is 40, should equal 180, because it's another line, so of course it's straight, or a straight angle. And subtract your 40, and x is 140. Now I kind of picked a bad example here because the 140, 140, 40, and 40 are all going to be the same, but that's okay, you can see it anyway. If we take 100 and y and we add them together, we get 140, and we notice we had 140 several times. And also notice that this x here is 140. Notice the same here, 100 and z, these two angles here, 140. It's the same as that angle out there, which is kind of where I'm headed with this triangle exterior angles theorem. The sum of the two remote interior angles of a triangle equals the measure of the exterior angle. So first off, let's think interior. That means the interior angles. Remote means away from. Think about a remote island. We think of an island far away. Think of a remote control. It enables us to control the TV while we're sitting on the couch far away from it on the other side of the room. So remote is on the other side, away from, by itself. So the two interior angles that are away from the exterior angle that we're talking about. So here in this case we're talking about this exterior angle, 140 degrees. Notice the exterior angle is formed by a straight line coming off of one of the sides of the triangle. So we have 140 degrees right here. I want you to notice that these two, if we add them together, 60 and 80, that gives us 140. So 140 does in fact equal 140, and that's all we're saying. Measure this angle plus the measure of this angle will give us the remote exterior angle. So notice that they are away from one another. Let's look at a proof for this. Y'all have not seen proofs up until this point. A proof is a wonderful thing. This is why I tell y'all all the time that units 1, 2, and 3 of geometry are the most important piece of information that you can learn in all of high school. For the sake of a proof today, I'm going to look at a 2-column proof. So we're going to start with reasons in one column, and we're going to have statements in the other column. So let's look at our triangle here, and let's start off with our interior angles of a triangle, which we talked about yesterday. I'm not going to look into that again. So let's start by saying the measure of angle A plus the measure of angle B plus the measure of angle BCA equals 180, and that's because we have the sum of interior angles of triangles is 180 degrees. So that enables us to say that these three added together does equal 180. Now let's also notice we have a straight line here, and the measure of a straight angle is 180. So the measure of angle ACB plus the measure of angle BCD is 180 degrees as well. Now, by the transitive property, we see that this equals 180 and this equals 180, which means that this stuff will equal this stuff. So let's write that down for a second. The measure of angle A plus the measure of angle B plus the measure of angle BCA will equal the measure of angle ACB plus the measure of angle BCD. Now there's a little bit of a trick here because apparently I wrote my letters in different directions for my angles, but let's notice BCA is the same as ACB. We notice that's the same angle, and I just have my letters backwards, but they're still the same angle. So if I have this angle on this side of the equation and this angle on this side of the equation, I can subtract that from both sides. And if I subtract this on both sides, I'm going to call it BCA so y'all see they are the same. And that's due to our subtraction property. There is a C in there, I can spell. Property of equality, which enables us to subtract on both sides. That will give us the measure of angle A plus the measure of angle B equals the measure of angle BCD. Notice that these cross out and these cross out. I'm left with the measure of angle BCD and then A plus B. So this is a proof. I guess I should have written this in this box actually, but that's okay. Y'all see that the measure of angle A, which is an interior angle, plus the measure of angle B, which is an interior angle, equals the measure of angle BCD, which is an exterior angle. So this is the proof. These are the reasons that we can make these statements that show us that this exterior angles theorem, is true. So all you're going to do is take your two interior angles, add them together, and their sum will be equal to the exterior angle.